Good morning, good evening, good afternoon, whatever the time may be that you're watching this lovely YouTube video for Period Stats. Good to see you all. If you haven't hopped on to our 9 a.m. to 10 a.m. math Zoom office hours, please do so so I can see your smiling face. We're going to start section 6.3 today, and I was just going to do a voiceover on the PowerPoint presentation, but I knew you wanted to see what I was looking like these days. Still got my haircut that's hopefully going to last for a month, and still hanging in there, and I hope you're doing the same. If you haven't already done so, go to today, Thursday the 26th, assignment page, and I have a link there for you to download the PowerPoint, so that way you can follow along. Or if you've got your text at home, it's the exact same information out of your text. And just in a nutshell, just to kind of summarize what we're going to talk about today with this applications of normal distributions, we're going to be doing what you did in section 6.2 with kind of just generic scenarios, calculating area and probability under the curve using z-scores from -3.5 all the way over to +3.5. But now this time we're going to kind of overlay scenarios on there and do some actual useful, productive calculations and determinations of probability. And if you remember in our earlier discussions on standard normal curve, is that area underneath the curve is actually, it has a dimension and size and weight to it that directly corresponds with exact probabilities, all right? If you'll need, the other thing you'll need is that table that I gave out in class, and you might want to have that little kind of handy-dandy sheet of those 6.1 through 6.7 examples, which kind of gives you just about every way to read area underneath the curve. All right, if you don't have that table, it's actually in Appendix B in your textbook, Table 3. All right, so here we go. And you can read along, and I'm just going to talk. All right, so it says, we've learned in Table 3 how to convert information about the standard normal variables into probabilities using z-scores. All right. Now we're going to actually put some real life situations to it. All right, and that's what this says. And as long as the information that you're provided, the calculations that you've been asked to do, says it's a standard normal curve, this works every time. And as we've discussed in class, just about any set of data can be kind of wedged or forced into quote-unquote a standard normal curve. All right, and the way they do that, if it's not standard or normal initially, you can keep increasing the number of trials that you have in your database, and all data will trend towards a standard normal curve. All right. And if you remember, z-score is how many standard deviations are you from the mean, which cuts that curve right down the middle with half the data on the left and half the data on the right. So it's x being any value of your data minus the mean of that data over the standard deviation. So here's kind of the written out formula. Here's the more precise using the symbology formula, which you should be familiar with by now. All right. So we're going to use the IQ data that we've used in several other examples. And if you remember, IQ is kind of your mental age over your chronological age. And 100 is where you should be. If your mental age and chronological age are in exact sync with each other, it should equal to 1 times the 100 gives you that 100. All right? Sometimes a little above, sometimes it's a little below. So in this situation, it's going to ask you, if you pick someone out of a pool of out of your sample, and ask what is the probability that person has an IQ of greater than 100 but less than 115. All right. So we're going to have to actually calculate two z-scores. All right. So it's asking you for this purple or shaded area on the graph here. All right, with 100 being the mean. All right. So it's fairly easy to calculate because you know that mean cuts that graph right in half, and you got 0.500 of the data over there. So we've got to determine what that z-score is, and it's already on this graph. So I'll just kind of walk you through the mechanics of how to do that, because we're going to do some sample problems on this in a little bit. So we got to determine, you don't really at this point don't know that it's 0.94. So We're going to go through the calculations, and if you look at the table here, there's your formula for calculating a particular z-score, and with a z-score of 100, which is your mean, which you shouldn't really even have to calculate, because it's 100 minus 100 over the standard deviation of 16, and you know that equals 0. Right? But if you do, this always works. So we also need that the z-score for a IQ of 115. So applying the same formula, same mechanics, 115 minus 100 divided by 16 comes out to that 0.94 that was on the previous graph. So kind of gave you a little bit of a heads up of how that's going to look. All right. So if you think back to what we did in section 6.2, what we're going to do is we're going to find that area of a z-score of 0.94, and I'm going to go back here real quickly. You know, if I look up this z-score, it is going to give you all that area going back to the left. But we're only looking for the shaded purple area here. So whatever value I get for this 115 score, or 0.94 standard deviations, the only thing I need to do is subtract out this left half of the standard normal curve, which is always going to be equal to 0.5000. So mechanics are fairly simple and easy. All right. So if you look at table 3 in the back of your text, or the table that I printed out for you, the area to the left of a z-score of 0.94 is 0.8264, and we're going to subtract that left half of the curve out because we're just looking at an IQ score of 100 to 115, and you come up with 0.3264, right? Just doing the basic math. So another way, maybe more easily understood way of looking at this, is that 32.6% of the people are going to have an IQ between 100 and 115. Or if you select one individual, the likelihood of him having an IQ between 100 and 115 is 32.6%. Hope that makes sense. All right. Let me just, let's see here. Normal table, when you say table 3, that's that printed table, or it's table 3 in appendix B in the back of your textbook. If you remember relating this to SAT scores, which are important for you juniors and have been important for you seniors, on your SAT scores it'll say you scored in the 85th percentile, or you scored in the 95th percentile. Relating it to that IQ situation, that means you're way over to the right, and 85% of the people are at you or below or to the left of that. This is one way you can relate to something that you already know. All right? All right, so here's a little different application of this, a little different twist. It's not the best example, but we're going to muddle our way through it. It says the incomes of junior executives in a large corporation are normally distributed, so we can use the standard normal curve and z-scores and all that good stuff. And they're getting ready to cut back, which is kind of apropos with what's going on right now, junior executives with earnings, and they're not going to cut anybody back, that's within $4,900 salary of the mean or the average salary for that particular company. All right? And they're kind of giving you a heads up, if this represents the middle 80% of the incomes, what is the standard deviation of the salaries of this group of junior executives? All right, so we've got enough information here to start kind of working our way through it. All right? So the middle 80%, all right, if you look at a graph, and if you look at, I think it was 6.5, I think on that examples we did a week and a half ago on Friday, middle 80% here, all right? So this is these, this area right here would be actually 0.40 here and 0.40 here, 0.10 here and 0.10 here. So this would be actually 0.900 going all the way back to the left, all right? And this would be 0.100 going back to the left, all right? So if using the table kind of working from the inside out, we'll take in the area under the curve and then looking at the corresponding z-scores, and because of it being symmetrical, you've got a z-score of negative 1.28 and positive 1.28. So that's $4,900 within the mean of this particular company's salary base, all right? But we just don't know what that mean is. But we've got enough information to work this out. take a look at that either on the YouTube, or you should have the printed, hopefully if you were able to print out the PowerPoint, that's great, or it's also in your textbook. All right, so let's look at this mathematically and see where it takes us. So $4,900 is the difference between the x value at B and the value of the mean, all right, in the numerator of formula 6.3, all right. We talk about the numerator, that's the thing on the top. So this is this right here, all right. So we've got this, all right, and we also have the z-score of 1.28, and actually negative 1.28. We just don't have what the standard deviation is, all right. So if we do the math, all we do is we multiply both sides by the symbol, and we divide both sides by 1.28, and we end up with the standard deviation being $3,828.12. All right. So that is the current standard deviation of the salaries of the junior executives. It's $3,828. So what's that tell us? Well, actually it didn't tell us anything. But basically it means that if I divide this into this $4,900 is probably what, about 1.3 standard deviations either side of the mean. All right. Kind of jumping around here and just kind of recapping a couple of things on these last couple slides. If they ask for you what's the probability someone has an IQ of 125, and if you relate this back to the graph, is 1.25 or 125 on the IQ score would be over to the right of the mean, probably in the 1.5 standard deviation, somewhere thereabouts, all right? But 125 is just a vertical line, and how are you going to get an area for a vertical line? And what this is going to tell you to do, and kind of walk you through this, is I need some way to measure that area of 125. So what we're going to do, in kind of in a nutshell here, is we're going to look, and I'm kind of breezing through this, is our 125 measurement is going to take that area between 124.5 and 125.5. So we're just going to go 1/2 a point either side of whatever that score is to give us an area. So we'd find out what the standard deviation of 124.5 is, and what the standard deviation for 125.5 is, or how many z-scores, and then we would get the corresponding area between the z-score of 124.5 and the z-score of 125.5 to determine what the likelihood is of selecting or someone having an IQ of 125. All right, let's see. I think that's it. I hope everything's going well for you. I've got a problem set that corresponds with this. I'm going to look at some other videos that I may link also to this if you want another person's perspective on it. There's both on the announcements page and the assignment page, I'll put the page numbers of section 6.3 that you probably would want to read in the textbook. I hope you're doing well. If you have not checked in with me on the Zoom meetings in the morning, do so this week to get full credit for the work you've submitted this week. Hope you're doing well. Look forward to seeing you at 9 a.m. here one of these next couple of mornings. We'll see you.